Find the value of the trigonometric ratio as a fraction. So we're given this right triangle. All three sides are given to us. I have angles too, but no information about that except the fact that you're 90. And it's asking us to find sine of C. That's not sin C. That's in Ohio. Cincy? Cincinnati? Anyway, so if we are ever asked to find sine C or cos C or tangent C, you are going to use this little acronym, SOH CAH TOA. Now, what we do is we take a look at the angle that we care about and we look at the sides compared to the angle. For example, 35, no matter what's the hypotenuse, 28 is going to be opposite of C, and 21 is next to it, which means adjacent. So SOH CAH TOA tells us, look, if you're using sine, you care about the opposite and the hypotenuse. If you're using cosine, you care about the adjacent and the hypotenuse. And if you're using tangent, then you care about opposite over adjacent. Now we're using SOH. And SOH means the sine of whatever angle you're using, in this case C, is going to be the opposite side over its hypotenuse. Okay, so the opposite side, according to C, is 28. 35, no matter what, is your hypotenuse. So sine C is going to equal the hypotenuse on the bottom and the opposite on top, 28 over 35. And that's it. That's just the trigonometric ratio. I can't do anything with that, can't simplify it. We're going to leave it like that. And it says leave it as a fraction, so we're going to leave it as a fraction. So sine of C in this case represents 28 over 35. Find the value of the trigonometric ratio as a fraction. So we're given a right triangle. All three sides are there. No information about the angles except that's 90. And we're being asked to find cosine of C. Not cos, cosine of C. Whenever you're asked to find sine of something or cosine of something or tangent of something, you use the little acronym SOH CAH TOA. What that does is it tells you, look, if you're finding sine or if you're finding cosine or if you're finding tangent, you care about either opposite sides, a hypotenuse, or an adjacent side. Now, if we take a look at C, okay, I'm being asked to find the cosine of C. I'm using this one because this is saying the cosine worries about the adjacent side and the hypotenuse. So I care about finding cosine C. Now, if I'm asked to worry about the adjacent side, according to C, means the side next to it that's not the hypotenuse. 27 is right next to it. The hypotenuse is 45. Don't be like, oh, well, 45 is adjacent too. Yeah, it is, but 45 specifically is the hypotenuse. So this stands for cosine of your angle equals the adjacent side over the hypotenuse. Adjacent over the hypotenuse. In other words, cosine of C is the adjacent side, which is 27 over 45. Now, in this case, it looks like I can divide both of these by 9, so I can simplify this further and say that cos C is 3/5. Now, depending on the teacher that you have, they might not care about that. They might just be happy that you notice that it's 27 over 45. But if you notice that you can simplify it, simplify it. But there we go. There we go. There we go. Like and subscribe. Find the value of the trigonometric ratio as a fraction. Tans. That's what I get in the summer. What we have here is we have a right triangle. All three sides are given. 90 is given. Nothing else, though. No other angles. But we are being asked to find the tangent of angle Z. Now, if you're asked to find a trigonometric ratio, you are going to use this clever little phrase, SOH CAH TOA. Now, what this does is this tells you, listen, if you're trying to find sine, you're going to use this one. If you're trying to find cosine, you're going to use this one. If you're trying to find tangent, you're going to use this one. We're trying to find tangent, so we're going to use this one. Now, there's multiple things that we need to worry about here. I care about Z, this one Z. Okay, that's my Z angle. Now, what TOA stands for is the tangent of whatever angle you are trying to find has to equal O and A. What is O and A? O stands for opposite, and you always put it over the other letter, which is adjacent. So this would be adjacent over hypotenuse, opposite over hypotenuse. But in this case, we're trying to find the tangent, which is opposite over adjacent. So if you're like, well, what's opposite over adjacent? Well, we compare the opposite side and the adjacent side to Z. So the opposite side is going to be the side opposite of Z, which is 21. The adjacent side is going to be the side next to it. And if you're thinking 35 and 28 are both next to it, yeah, but 35 is a hypotenuse. We want the side next to it that's not a hypotenuse, so not you and yes, you. So the way we set this up now is we say, all right, tan Z is going to equal the opposite side, which was 21, over the adjacent side, which was 28. And you might notice 21 over 28, does that simplify? It sure does. 28, 21, divide them both by 7, 3/4. And that's my answer. Tan Z is 3/4. I've heard of Gen Z, but tan Z, that's all we're trying to find here. Find the value of the trigonometric ratio as a decimal. We're given 3 right triangles, and we are being asked to find 3 ratios as a decimal. Whenever you're asked to find the trigonometric ratio, you are going to use this cute little phrase, SOH CAH TOA. Now, SOH CAH TOA means if you're trying to find sine, then you have to worry about the opposite side and the hypotenuse. If you're trying to find cosine, then you worry about the adjacent side and the hypotenuse. If you're trying to find tangent, then you worry about the opposite side and the adjacent side. Let's do one at a time. All right, sine of Z, there's my Z. When you do sine of Z, you care about sine Z equals the opposite side over the hypotenuse. Now, well, let's do one thing at a time, hypotenuse. Now, we compare Z with these numbers. We're going to say, all right, well, if you're just looking at this and not really worried about the letters and you're like, well, which one's opposite, which one's adjacent? Look at Z. The opposite to Z is 30, so my opposite is 30. My hypotenuse is always 50 because 50 is going to be opposite of the right angle. 30 over 50 simplifies to 0.6. So sine Z is going to be 0.6 in this one problem right here. You know what? Jesus died for that. Our sins. Cosine Z. All right, so there's a new Z right there. And cosine is going to use CAH, which I believe is slang for friend. Now, cos Z has me caring about the adjacent side, adjacent means next to, over the hypotenuse. So if you look at Z over here, and if you're thinking, isn't 12 and 15 adjacent? Isn't 12 and 15 both next to Z? They sure are. But 15 is the hypotenuse, which would make 12 the adjacent side. Now, 12 over 15, this fraction is not near as friendly as this, but if I notice that both of these are divisible by 3, that becomes 4 over 5. And I know 4 over 5 is the decimal 0.8. So cos z is going to be 0.8. Let's get a new color and do a new problem. Tan x. Now, tan x, where's my x? There you is. Tan x is going to use TOA. So tangent x is going to be the opposite side over the adjacent side. Okay. Now, looking at x, the opposite side of x is 30. I can handle that. I have two adjacent sides, 40 and 50. Oh, but 50 is opposite of the 90-degree angle, which makes 50 my hypotenuse. So my adjacent side is going to be 40. 30 over 40 is the same as saying 3/4, and I know 3/4 is 75 cents. So that's what tan x is. Lots of puns in this one. I like it. I enjoy it. Hopefully that gets me more than 10 views. But yeah, there they are. Trig values written as decimals. Fun, fun, fun. Find each angle measure to the nearest degree. What they're asking us to do is find each of these 3 letters. Here's the problem for each of these 3 letters. There is a trig function in the way. Sine is in the way, cosine is in the way, tangent is in the way. So I have to get rid of each of these trig functions legally. Now, the way I do that is I use the inverse trig function. So what I'm going to do is I'm just going to rewrite this guy, give myself some space. I'm going to have to do that with all 3 of these. Okay. And I'm definitely going to need a calculator for this one. You guys can't do these on your own. Back in the day, people had to use slide rules. Those were a nightmare. Now, my issue currently, all I did, by the way, was rewrite that. My issue currently is sine is in the way. You can't divide sine from both sides. What you do is you take what's called the inverse sine. Some people call this the arcsin, same thing. Inverse sine. What the inverse sine does to a regular sine is it gets rid of it. Okay, so now b is all by itself. The problem is I have to go to a calculator and find out what the inverse sine of 0.4848 is. So if you're using like a TI-84 Plus, you're looking for that inverse sine button. If you're using Desmos, you have to hit functions and use that button. So I'm actually going to go off to the side here, use my Desmos, and I'm now typing in, I'm not typing in anything. I'm hitting the inverse sine of 0.4848. Make sure your calculator is set to degrees. There's something called radians that looks like RAD. You don't want that. Even though it sounds cool because it's rad, you don't want that. Now, I typed it in my calculator, and I actually think I'm set to radians. I am. So I made it degrees. And according to this, I have 28.999, and it wants me to round it to the nearest degree. So 28.999 is 29 degrees. Okay? So what that means is if I were to run to a calculator and type out what's sine of 29 degrees, I would get 0.4848, blah, 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 blah. It's never going to be a nice number most of the time, unless you're dealing with like zeros and 90 degrees and stuff like that. But most of the time, it's going to be very unpleasant. I'm going to write this guy again, cosine A, leave myself some space, 0.7431. In order to get rid of cosine, I have to inverse cosine. Some professors, some teachers call that arcsine. Inverse cosine, both sides. That crosses the coses out. And I run to a calculator. I type out inverse cosine of 0.7431, and I get 42.0038, so I'm going to go with 42 degrees. Okay? Same thing here. All right, I'm going to write out tan W equals, give myself some space, 19.0811. In order to get rid of tan, I'm going to inverse tan both sides. So inverse tan, that gets rid of tan. Some people call that arctan. And now W is going to equal whatever the inverse tangent of, what was it, 19.0811. I get 86.99999. 86.99999 is awfully close to 87 degrees. Now, I am on an iPad using a Desmos app. Make sure, whenever you're in geometry class, pre-calc is a different story, but when you're in geometry class, make sure your settings, like you might have to hit that little wrench thing, make sure your settings are set to degrees. Okay, it says it right there. If you use radians, you're going to get a very small number every time for this. Maybe not too small for that, but you're going to get a very small number. If you're using like a TI-84 or like a Casio or some kind of smart calculator, graphing calculator, it might say something like rad next to degrees. Like if you hit the mode button, it'll probably say rad in degrees. You want the degrees. Okay, so make sure your calculator is set. But that's how you do it. If you are told sine of an angle equals stuff, inverse sine it, inverse cos it, inverse tan it, and you'll get that. Dunzo. Use SOH CAH TOA to find the missing angle. I'm going to call this angle x just for math's sake, and I'm supposed to find that missing angle. Well, I have a right triangle. That's extremely important. I don't have the other angle, but I do have two sides. It's telling me to use SOH CAH TOA. So this is what I'm going to do. I'm going to take a look at x. 42 compared to x is my hypotenuse. 40 compared to x is the opposite side. So I am going to choose the three of these that involve the hypotenuse and the opposite side, and it's u. So what I do whenever I'm using SOH is I get a needle and thread. I say sine of my angle, which I called x, is going to equal the opposite side over the hypotenuse. Okay, so I don't know x. So sine x equals the opposite side, which is 40 over the hypotenuse, which is 42. Excuse me, math teacher Goat, you left a whole lot of space there. Is there a reason? Yes. I have to find x. X here represents the angle measure. Sine is in the way. So just like Christ did for us, I have to wash this sine away by inverse sining both sides. In order to get rid of the sine, you inverse sine both sides, and that cancels out the sine on the left. The problem is I have to find out what inverse sine of 40 over 42 is, which I have zero clue. So you always, not always, but most of the time in geometry, you're going to have to run to a calculator, which I'm on my iPad. I'm on Desmos right now, and I'm typing out inverse sine of 40 over 42, and I get 72.2472. So I'll write all those out, 2472. Now, this is an angle measure. X is nowhere in the original problem, so I'm not going to circle this for two reasons. Again, because X is nowhere in the original problem and I don't have my degrees. So I'm going to write out 72 point, and if you want to round this to 2 decimals, fine, 25 degrees. But that's my missing angle measure. Okay? And I use SOH CAH TOA to do it. I had to do inverse trigonometry to do it, and I landed on that guy. Again, when you have to use a calculator, make sure your calculator has a mode set to degrees, which means if you're using like a TI-84 plus or something like that, you hit mode and you make sure it's in degrees. If you're using Desmos, you click the little wrench looking thing and make sure it's set to degrees. Otherwise, it's going to give you a completely wrong number. But that's the right number, and I'm happy. Use SOH CAH TOA to find the missing angle. First things first, you're being asked to find the missing angle, and I know if we have to use SOH CAH TOA, we're going to need a calculator. So make sure your calculator is set to degrees. So if you're using Desmos, you're going to hit the little wrench and set it to degrees. If you're using a graphing calculator, make sure you go to mode and set it to DEG and not RAD. All right, I'm being asked to find this question mark right there, and I'm going to call it X. I'm given a right triangle, and I'm given 20 and 13. Now, I have to compare 20 and 13 to X. 20, no matter what, is my hypotenuse. 13 is right next to X, which means 13 is going to be my adjacent side. No opposites here. So, just like if I were calling my friend, I'm going to use CAH, because CAH is slang for friend. CAH is cosine of your angle equals the adjacent side over your hypotenuse. So according to what I have, I'm going to write out cosine of the angle that I need to find, which I did call X, is going to equal the adjacent side, which is 13, over the hypotenuse, which is 20. If you're thinking, wow, you sure unnecessarily left a whole lot of space here, I did leave a whole lot of space, but not unnecessarily. My job is to find X, that missing angle. Cosine is in the way. The way you get rid of a trig function is you inverse trig both sides. So I'm going to inverse cosine that guy, and I'm going to inverse cosine that guy, which is definitely going to require that calculator I was talking about. The inverse cosine and the cosine cancel each other out. I run to a calculator, and I type out the inverse cosine to the -1 of 13 over 20, which I'm using Desmos. My Desmos says 49.4583, blah, 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 blah. If you get a really small number. Now, by the way, if I look at this, you're never supposed to look at a picture and say, yeah, that looks right. But it does look right. That does look like it's in the 40s as far as angles go. If you never set this to degrees and it was set to radians, it would give you a very, very, very small number, and you would know that you're wrong. Set it to degrees. Now, I'm not done yet for two reasons. First off, I never used X in the original problem. I created X, so I don't need X. Second, this is an angle, so I have to put degrees, and I am going to round this to 2 decimal places. So my final answer is going to be 49.46 degrees. That's my guy. All right. So in this case, X, 20 and 13 were my hypotenuse, and my adjacent, which is A and H. Use cosine, use inverse cosine, type it in your calculator or Desmos or whatever it is that you're using, and you're good to go. Use SOH CAH TOA to find the missing angle. So I have to find that angle right there. I'm going to call you X. Now, whenever you're doing right triangle trigonometry, and that's what this is, because SOH CAH TOA stands for sine, cosine, and tangent, which is trigonometric functions, you have to always use a calculator. Not always, but like 99% of the time. Make sure if you're using Desmos, you hit the little wrench and have it set to degrees. If you're using a graphing calculator, a scientific calculator, make sure it's set to degrees and not radians. Radians are something completely different. You'll find out in pre-calc. Now, I'm looking at this missing angle here that I called X. I have no other angles, so it's not like I can subtract from 90 or 180 or anything like that. That's no good. So I have to use these two sides right here. What I have to do is compare 27 and 38 to X. Now, the obvious one is 27 is opposite of that. 38 is next to it. So is that my adjacent or is that my hypotenuse? Well, this is my hypotenuse, so you're my opposite for sure, and you're my adjacent for sure, and I don't have information about the hypotenuse unless I wanted to do Pythagorean theorem, but that's a waste of time. So opposite, adjacent, TOA. Now we're going to set up what TOA means. TOA means the tangent of an angle is going to equal the opposite side over the adjacent side. Okay, so here I have tangent of x equals the opposite side, which I called 27, over the adjacent side, which I called 38. Wow, I sure left a lot of space there, didn't I? I did, and I did that on purpose because I have to get x all by itself. And the only way you get x all by itself is to get rid of that tangent. So we get rid of tangents by taking the inverse tangent of both sides. So we write out the inverse tangent of both sides. That allows us to cross out those tangents over there. Now x is all by itself. I am running to my graphing calculator right now. And if you're using Desmos, you hit functions. If you're not, if you're using a graphing calculator, you probably have to hit second tangent. And then the little tangent inverse pops up. And then you type out 27 over 38. And according to the Desmos that I'm using, I get 35.9347795, blah, 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 blah. Now, I'm not done. I'm not going to circle that for two reasons. Reason number one, I never used x in the original problem. I created x just because. Also, I don't have a decimal, and that's too many numbers. So I'm going to round this off to two decimal places and say that my answer is 35.39 degrees. All right? And you could look at this and say, yeah, that looks about right. If for some reason you did this and you got a ridiculously small number, that's because you have it set to radians. And that's not rad. It's 90s slang for really cool. Find x using SOH CAH TOA. All right, I have a right triangle. I have x, which represents what looks to be a hypotenuse, so I'll label you hypotenuse. I have an angle right here, and I have a side, but that's all the information I have. So it's not like I'm given another side I can do Pythagorean theorem. I have the angle, I have two sides, and that's it. Well, SOH CAH TOA helps us when we only have two sides or only need two sides and we're given information about an angle. So I'm looking at my angle 72 degrees and I'm comparing what x is to 72 degrees. Well, I already said it's my hypotenuse. So what is 6? 6 is directly next to my angle, which is my adjacent side. Now, before you're like, well, isn't x also adjacent? It is, but that's my hypotenuse. And stop talking like that. So I need to choose the one of these that uses the adjacent side and the hypotenuse. And why don't I call my friend or my CAH? Paul Walker one time said that in Too Fast, Too Furious like 20 years ago. He's like, forget about it, CAH. If you've seen it, you know. All right, so if we're using CAH, we are going to set up cosine of my angle, which I'll call A because I'm afraid to call it X, is going to equal my adjacent side over my hypotenuse. And now I plug in what I know. I plug in cosine of my angle, which I know my angle. We did previous videos where we didn't know my angle, but now I do. Is going to equal my adjacent side, which I know is 6, over my hypotenuse, which is x. So in a previous problem, I was trying to find the angle and we needed to use inverse cosine, not here. What I do is I run to whatever calculator I have or Desmos or whatever I have and make sure your calculator is set to degrees. So if you're using Desmos, hit the little wrench thing and go to degrees. If you're using like a TI-84, make sure you go to mode and make sure it's in degrees. And you're literally going to type out cosine of 72, which I am actually doing that this very second. It's giving me the fraction 0.30901, so I'll just call it 0.309. That's going to equal 6 over x. My job is to solve for x, so this is what I'm going to do. X is on the denominator. I don't like that, so I'm going to create a denominator for you and look at this out of proportion. You don't have to do it this way. This is just the way I'm doing it. And if you don't like it, watch like friggin' Khan Academy or something. They're just not cool and funny. Whenever you have a proportion, crisscross applesauce. So I'm going to multiply 0.309 to x, which is 0.309x, and you're going to set that equal to 6 times 1, which according to my calculations is just 6. You divide both sides by 0.309, divide both sides by 0.309. So I'm actually going to type that out right now. 6 divided by 0.309, and I get 19.41747. So depending on how picky, I didn't tell you where to round it to, so let's round it to 2 decimal places. 14.42, no units to worry about, don't have to worry about inches or feet or anything like that. So that's how you find x. We're finding a hypotenuse using trigonometry. Awesome. Find x using SOH CAH TOA. So SOH CAH TOA means like trigonometry stuff, sine, cosine, tangent. I'm given this right triangle here, which is the only times I can use sine, cosine, and tangent in geometry. And I have to find a missing side. Not find an angle, find a missing side. I have an angle, and I'm going to compare these sides to that angle right there. X compared to 37 is an opposite side. 12 compared to 37 is adjacent, and the side that I don't care about is a hypotenuse. So I need to pick the guy that cares about opposite and adjacent, and that's TOA. So what TOA stands for is tangent of an angle equals the opposite over the adjacent side. Make sure when you do this, your calculator or Desmos is set to degrees. So go to mode or go to that little wrench thing and make sure you're set to degrees. But I'm going to set this up according to this. Tangent of my angle, I have my angle, it's 37, is going to equal my opposite side, which I don't know, over my adjacent side, which is 12. Do you know what tangent 37 is? I don't. I doubt you do. So I'm typing it in a calculator right now. Tangent 37, according to Desmos, is 0.753554. An unnecessary amount of decimals, but I always like to write more than I need. So tan 37 turns into that. Nothing happens on the right side until now. Is x all by itself? No, it's not. 12 is being divided from it, but this is just an Algebra 1 problem. Multiply both sides by 12. So I'm going to take that ugly number that my calculator has. I'm going to multiply 12 to it, and I get 9.0426 blah, blah, blah is going to equal x. So let's flip this around, clean it up a little bit. X is going to equal, let's round to 2 decimal places, so it's not 5 or above, give it a shove, 9.04, leave it as that. That is my x. Looking at the picture, that looks like it would make sense. I don't have to worry about feet or inches or units of measure here. There you have it. There you have it. Just make sure when you do these, you have your calculators, or make sure Desmos or whatever it is that you're using is set to degrees. Otherwise, you're going to get terrible answers. Find x using SOH CAH TOA. All right, so x is over here. I'm given a 30, 60, 90 triangle, and Satan is tempting me to use that, but I'm not going to. Maybe I will. I don't know. Maybe I'll just give in to my temptations. But I can't even do anything right now. I'm just given a hypotenuse and 60 degrees. That don't help me. But over here on this triangle, I'm given 39 degrees. I'm given 38. That's it. Oh, if only I could find out what that side is. If only I can find out, then I would have a side here, 60 degrees and x, and that would make life a lot easier. So that's what I'm going to do. I am going to look at this triangle right here. I have an angle of 39 degrees. 38 compared to 39 degrees is my adjacent side. I have to find this side. This side, which I don't want to use x, so I'll call it y. This side is opposite of my 39 degrees. So I'm going to use the trig function that involves the adjacent side and the opposite side, and that's TOA. When we set up TOA, we say tangent of my angle is the opposite side over the adjacent side. Tangent, opposite, adjacent. So I'm going to fill in what I know. Tangent of 39 is going to equal the opposite side, which I don't know, over the adjacent side, which is 38. My issue right now is I have zero clue what 39 degrees is. Make sure if you use Desmos, if you use a graphing calculator, you have your mode set to degrees. Otherwise, this is not going to work. So I'm going to go to a calculator right now, and I'm going to type out tangent of 39 degrees, and it's telling me that it's 0.80978. So 809. We'll just make it 9.8 right there. Okay, I'm rounding it a little bit. And that's going to equal y over 38. Okay, tan 39 turned into that. Is y all by itself? No, but it's over 38, and I know from algebra if I multiply both sides by 38, y will be all by itself. So let's take that number that I typed into my calculator, let's multiply it by 38, and it's giving me 30.7717. So I will say 30.77 is y. Now, y is really not called y. I just called it y, so I'm going to get rid of u. And I'm also going to get rid of my words because I don't want to confuse anything. Okay. What I do know is that this is 30.77. I also know that this is a 30, 60, 90 degree triangle, but I'm not going to use that. I'm just going to use SOH CAH TOA again. Okay, I'm going to look at 60 and compare this guy and x to 60. That guy is opposite compared to 60. X is my hypotenuse no matter what. And don't be like, it's also adjacent. Yes, but it's my hypotenuse. So I need the guy that uses my opposite and my hypotenuse, and that would be sine. So the way you set up sine is you say sine of your angle is going to equal the opposite side over the hypotenuse. And now we fill in what we know. Sine of 60 is going to equal the opposite side, which is 30.77 over the hypotenuse, which is x. So let's go to a calculator and type out sine of 60. I do know what it is because I teach pre-calculus, but we're going to type it out anyway. It's 0.866025, so I'll leave it like that. That equals 30.77 over x. Now, x is in the denominator, so I'm going to use this little trick where I'm going to turn this into a proportion so I can do crisscross applesauce. Do I have to do it this way? No, I can multiply both sides by x, but I'm not gonna. I have it set up as a proportion now. And so I'm going to multiply diagonals, so 0.866 x, can't forget that, is going to equal 1 times 30.77. I think I can handle the math for that one. In order to get x all by itself, we divide everything by 0.866, divide everything by 0.866. And let me just do this off the top of my head. Just kidding. I'm typing it into my calculator. 30.77 divided by 0.866 0.866, and I get 35.5311. So we will say x is 35.53 because it's 1, 1, and I'm not going to worry about those ones. No units of measure, no inches or anything like that to worry about. I am solving for x, so I'm allowed to say x equals. But yeah, kind of a crazy problem. We had to use SOH CAH TOA twice, but listen, man, I love it. So if I had to use it 50 times, I'd use SOH CAH TOA 50 times. Making these videos, I basically have. So if you appreciate that, smash that like button. Find the area of the entire triangle. There is an area formula, okay, that involves trigonometry. It involves sines, but I'm not going to use that. I'm going to use this area formula right here. Half of base times height. That's a B. Half of base times height. I don't have my height. And you know what else? I don't have my base either. So this problem is just very unpleasant. Now, I'm going to cheat a little bit. All right, and please don't get mad at me. I'm going to cheat a little bit. This guy right here, okay, this guy is a 30, 60, 90 triangle. I know with 30, 60, 90 triangles, whatever my smallest leg is, my hypotenuse is going to be 2 times that, and my second leg, my longer leg, is going to be a times root 3 of that. So if I'm given the smallest leg, multiply it by root 3 and I get the longer leg. I have the longer leg. So if I want to find this height right here, I'm going to divide by root 3. So I'm going to go to my calculator because I'm going to need my calculator a whole lot anyway. I'm going to divide 29 divided by the square root of 3, and I get 16.7431. So I'll put 16.74. 16.74. All right. I'm not going to clear that. I'm going to leave that there. Now, that's great. Now I have my height, but I still don't have the entire base. This is what I do have. I have this triangle on the left. I have an angle. I need to find this. I'll call you X, and I have a side next to it. So I'll call you my adjacent side. I'll call you my opposite side, and I'm going to use SOH CAH TOA. Now, if I have my adjacent side and I have my opposite side, that uses the TOA in SOH CAH TOA. And so you set up tangent of your angle, which is 52, is going to be the opposite side, which is, I don't know, over the adjacent side, which is 16.74. I run to my calculator and I type out tangent 52. Make sure your calculator is set to degrees and not radians. And I get 1.27999. So I'll put 1.28. And that's going to equal x over 16.74. Do I have my x yet? No. But if I multiply both sides by 16.74, I will have exactly what I need, 16.74. Good job giving myself a lot of space, Nick. That's my real name. My real name is not Math Teacher Goat. I just call myself that because I'm trying to get more followers. But what I'm doing is I'm running to my calculator right now. I'm typing out 16.74 times 1.28, and I get 21.426222. So I'll do 21.426. X represented that missing side right there. So let's get rid of it. And now call it 21.426. So let's write this triangle out. Let's draw the exact same triangle. As you can see, it's perfect. I know the height. It's 16.74. I know if I add these two numbers together, I get my entire base. So 21 plus 29 is 40. So this whole thing is going to be 40.426. So to find the area, I use this formula and do A equals half of my base, which is now 40.426, times my height, which is 16.74. I'm not even going to pretend that I know what this is, so I'm going to my calculator right now and I'm typing it out. While I'm doing that, make sure you smash that like button. Make sure you crush the subscribe button. Am I sounding like a YouTuber now? Times 16 point, what was it, 74? 16.74. And I typed out the wrong number. 338.365, so I'll call it 37. I don't have a unit, so I will call it square units. That's the area of this whole thing. Now, there's a way that you can do this a whole lot faster using a calculator and sine and stuff like that, but that's what I did here because that's what I was asked to do. If you want to know how I do it faster, watch the next video on your playlist. And don't forget to smash that like button, please. Give me some of that sweet YouTube money. Use SOH CAH TOA. All right, Km is 10 root 3 Km. All right, this whole thing is 10 root 3. The measure of LMN, which is this guy, is 60 degrees. Find Ln. Okay, so what I have is a rhombus. I have to find, at the end of the day, Ln. Okay. So I'm going to use the fact that this whole thing is 60 degrees. This whole thing is 10 root 3, the whole thing. But I only want this part of the triangle, which is half of that. So half of 10 root 3 is 5 root 3. Okay, so let me get rid of that 60 because I now don't want that whole 60. I know that this length right here is 5 root 3. You would be 30 because if this is a rhombus, then the diagonals bisect the angles. And I'm going to use this triangle right here to help me find Zn. Once I find Zn, multiply it by 2, that gives me Ln. So I'm going to use that triangle, which was 30 degrees. This guy was 5 root 3. And I need to find this guy. Once I find this guy, that gets me Zn, multiply it by 2, and I get the whole thing. So what do I have? I have 30 degrees. Now, the devil is saying, use special triangles, boy. Use it. It says use SOH CAH TOA. So get thee behind me, Satan. I'm going to use what the rules say I use, because the rules are not meant to be broken. So I have 30. 5 root 3 is opposite of that. No, it's not. It's adjacent. Are you down with OPP? All of that. All of that just to be stupid. All right. 3 root 5 is adjacent. X is opposite. So I need to use the one of these three that deals with adjacents and opposites, and you're my guy. So tangent of an angle is going to equal my opposite side over my adjacent side. Let's plug in what I know. Tangent of 30 is going to equal my opposite side, which is x, over my adjacent side, which is 5 root 3. So tangent of 30. Run to your calculator, make sure it's set to degrees, and type out tan 30. You can hit functions or you can just hit the tan button in a regular calculator. Tangent of 30 is 0.57735, so I will write that out, 0.57735, and that equals x over 5 root 3. Is x all by itself? No. I have to multiply both sides by 5 root 3. So this is me doing that. That allows me to cancel that out. X is going to equal, now let me run to my calculator again and take this guy and multiply it. So hit the times button, 5 root 3. Wouldn't you know it? I get a perfect 5. It's if God is smiling down on us. Now this is 5 right here. Now again, if we didn't have that, and if you know special right triangles, you would know that if I give you the smaller leg, the longer leg is going to be 5 root 3. So this makes sense. Now Zn is 5. Ln is 2 times 5. So Ln is 10. I made a rhyme. No units to worry about, no inches, no feet, nothing like that. Fun problem. Use SOH CAH TOA, so sine, cosine, or tangent. All right, oh my gosh. TQ is 15. There you are, which means you're also 15. I don't know if that's going to matter, but I'm just doing it. TR, this whole thing is 20. I'm not going to write that out yet. XR is 11. Find the measure of angle XTS. XTS. All right. All right, so this whole thing is 20. This whole thing is 20, which means you're 9. Okay, so this problem is actually not near as bad as I thought it would be. Now, where did I get 9 from? If the whole thing is 20 and you're 11, then you're 9. Oh, 9, 11, never forget. So what I'm going to focus on is this triangle right here. That triangle right there where I'm being asked to find this angle. That's a right angle. You're 9 and you're 15. And I'll call this T because there's a T there. Okay, now if my job is to find angle T and I'm using SOH CAH TOA, I have an angle and I need to see what 15 and 9 are compared to that. So 9 compared to T is right next to it, and it's not my hypotenuse, so it's my adjacent. 15 is my hypotenuse, so I need the guy that cares about the adjacent and the hypotenuse, and it's CAH, as Paul Walker once said in Too Fast, Too Furious. What's CAH? CAH is cosine of your angle is going to equal the adjacent side over the hypotenuse. Now I fill in what I know. Cos T equals my adjacent side, which is 9, over my hypotenuse, which is 15. Wow, I left a whole lot of space there. Stupid me, stupid you, because T is not all by itself. We have to get rid of cosine. And in order for us to get rid of cosine, we take the inverse cosine of both sides. So I needed that space so I could do that. The cosines on the left are gone. Okay, I have to run to a calculator or Desmos or whatever and find out what inverse cosine of 9 over 15 is. While I do that, make sure you understand that your computer, your whatever it is that you're using, calculator, I'm trying to multitask and I'm doing a terrible job. Make sure your calculator is set to degrees, otherwise it's going to give you a terrible answer. This is probably going to be a terrible answer anyway, but yeah, it's not pretty. 53.1301. So we'll stop at 53.13. And that gives me that angle right there. XTS. So I'll finish this answer by saying the measure of angle STS TS equals 53.13 degrees. Okay. Use area equals half of little a little b sine big C to find area. Now, I'm given that triangle right here, and you're probably thinking, what's this? What's little a little b sine C? What does that mean? If I were to take just any regular old triangle, and you're going to see this a lot when you get to pre-calculus, your angles are going to be capitalized. It doesn't matter which one's A, which one's B, which one's C in this case. Okay, it doesn't matter at all. The sides opposite of the angles are going to be your lowercase sides. So A is over here, lowercase a. C is right here, opposite of that is lowercase c, and B is right here, opposite of that is lowercase b. So if we're going to use little a, little b, and big C, then we care about side angle side. So it's basically you're using, in a sense, SAS, which I use SAS all the time in my videos, but in this case we're using side angle side to figure this out. Oh look, side angle side. So I can call you little a, big C, and little b. So let me get rid of this, and let's find the area. The area, and I'm not going to use A for area because I don't want to make it look like the A that I just had written out. So area is going to equal 1/2 of A, which I called 8, B, which I called 6. Doesn't matter which one your little a and little b are because you're just multiplying anyway. Sine 87. So I'm literally just going to type this straight into my calculator, this whole thing. Make sure you have your calculator or a Desmos set to degrees, otherwise it's not going to give you a pleasant answer. So 6 times 8 times, I had that backwards, doesn't matter, sine of 87, and it's telling me 23.96710.8, blah, 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 blah. So let's finish this problem out by saying that the area is 23.967 centimeters squared. Okay? So that's using the trig area formula to find the area of a non-right triangle if you're given an angle and two sides, as long as the sides are attached. Done. Fun. Number 1.